Hi everyone, can you hear me? Great. Thanks for coming. My name is Tal MELAMED. I'm the head of security research at Protego Labs, Israeli-based startup for serverless security. And today we're going to talk about serverless top 10. Um, so before I start about me, you can read about me online. If you want to follow me, use one of those. I'm working at a company called Protego. We do serverless security solution. Of course, if it interests you, come back after that talk. Well, two talks. After this talk, you are all invited to the project showcase where I have another talk. So what are we going to talk today? Intro. Usually I give about 10-15 minutes intro about serverless because it's a relatively new technology, but I don't have time for that, so I'll make it short just to make you understand what are cloud functions, and then we'll dive into the top 10. So first, before reInvent, AWS latest reInvent, no one knew what serverless is. Usually this is the first question that people ask me after I tell them, yeah, I do serverless security, and they say, server what? So after the talk, after the reInvent, people start noticing it. And you can see most of the talk were about serverless, and after that, security, which is interesting because if I go to Google Trend and I look at serverless, you can see it's a constant increase over time. Yeah, people hear more and more about serverless. They want to participate, but if I do serverless security, which is what we're interested in, there's nothing. Maybe one, but that's me. So we're not really there yet in the security. People will start understanding after they're getting hacked, like always, like with every new technology. Oh, mobile, we don't need new security, right? Oh, sorry. But it's a thing. And how do I know? Because this is from last night. Palo Alto just acquired our competitors, so raises also our value, so that's also good. So people are starting to understand that serverless is a thing. And how do I know that as well? Is because all the major companies are doing serverless, providing that service. So Azure, AWS, GCP, Google, SAP, IBM, you name it. The big ones are going serverless. So what are serverless? What is serverless exactly? Just this is the only intro that you'll get about serverless. If you want, do some homework after that. So serverless is just giving you compute powers on the cloud. So I'll mention, usually I'll say AWS because they rule the market, but I mean every service provider. So for example, when you want to run your code, your application, a container spins up in the cloud. You do not have to deal with anything related to that container, and it's like a standard container that is built in for any of the functions. So this container runs your code, and when the code ends and finishes its execution, the container dies. It's not completely true. Maybe we'll talk about it later. So it only spins up when required, and you pay only for what you use. It is triggered by events, so it does not have to be what we're used to in the monolithic application. API call, code runs, back we get the output. It doesn't have to be like that. The power of serverless is that functions can be triggered from various different events, like uploading file, modifying a database table, time-based, like a cron job or something like that. It could MQTT, IoT, you name it. So it's not only API. It's a read-only environment, except from the /temp. So everything else is read-only, and you cannot modify it. So you only have the /temp library. So I said a container terminates when code finishes its execution. They are not wired to the internet, so you cannot SSH to the containers. The data is temporary. So again, when the container ends its cycle, they shut down everything that was there under the /temp is deleted. We'll talk about these wild asterisks after that. The code is inside the environment, so when the container spins up, it has the code there, so it knows what to execute. And also the keys that gives the function its abilities in the cloud are also there, and we'll abuse some of those during the talk. So I'm here to introduce the OWASP Serverless Top 10. So the current state of the project is an interpretation of the original OWASP Top 10 2017. We are running an open data call. If you are using serverless, that you're more than welcome to contribute. Of course, it's an OWASP project, so it's open. So currently we have a report that is the interpretation of the original OWASP Top 10, but the goal is to have a serverless tailored Top 10. We also have a Chinese translation. Thanks for, where are you? Yeah, hey. So we have a Chinese translation from OWASP China for this project. Okay, GIF doesn't work. Let's go. So let's dive. I don't have much time. So what I'm going to do is I'm going to go over each of the top 10, so I don't have much time, and we're going to see, and we're going to talk about why it's different and how do we need to deal with it. So injections. Why are injections on serverless are different than injection attacks on a regular application? First, there is no API input, not only API input coming in. You cannot put your barriers there. There is no firewall you can put. It's not yours. So you have, basically in serverless, it's code-centric, so it's only AppSec, which is why it's a very good topic at OWASP. So there are various of entry points for your code, for your functions, your application logic, that can come from multiple events. So this is why we refer to it as an event injection rather than what we're used to. The traditional injections still apply, SQL injection if you use SQL in the cloud, NoSQL if you use other NoSQL databases. Command injection, it works if you have a vulnerable code, but what you can do on the server is different. So for example, you don't have remote code execution or serverless server hijacking because there is no server. So we'll see how it works differently. So you have per language, of course, code injection because functions run with different languages. So most common one, like 80%, is Python and Node. Currently, you can also have C#, especially if you use Azure. Okay. And there are some new methods of injection attacks that come through different types of events. They weren't actually there or weren't very common in the regular app, which is, for example, MQTT, injection through emails, notifications, and different various of events coming in. Of course, the impact, and we'll get to that later in the top 10, the impact that you can do through an injection depends on what the function can do. So the ability to, well, it can be both a liability and an opportunity that you have to give, or it depends also on the service provider, but you can give different permissions for different functions. So if you think about it from the AppSec world, it's a dream, right? If you could take an application and give different permissions for each function inside your PHP code or whatever, it could be, it's a least privileged dream. So in serverless, it's actually possible because you can actually give, or in some providers you have to provide different permissions. So the injection impact, it depends on the permissions or what the capabilities of the function. So if before we had an attacker coming in through the only perimeter. Now on serverless, it can be through an API gateway, of course, but it can be also through different types of events. So there is no, here you can put your security controls, right? And everything goes through it, but you don't own anything that goes in. You have only the code that runs when an event hits. Let's see a demo. Again, I wanted to show a live demo, but we're short in time, so we'll settle for a video injection. Yep. No. Sorry. Oh, sorry. Okay, so we have a Slack chatbot here that interacts with me writing messages. Yeah, but it's also vulnerable to SQL injection, injection. Sorry, not SQL. It's also vulnerable to injection attack through a vulnerable library. So if you saw a sneak, it was a good continuance for that. So I am doing now require child process. So what I'm going to do here is I'm going to execute a child process within the function. And I'm going to send this to my address at ngrok, the simple HTTP tunnel here, a curl, through curl. So yeah, I got that. That request came from the container, from the Lambda function. Or, sorry, in this case it's a Lambda function. It could be also a cloud function, Azure function, or whatever provider. Now what I'm going to do, I'm going to use the same technique, but now instead of just sending /hack with nothing, I'm going to take the I'm going to archive the /library, which is where the code is, and then write it into a tar file under /temp because it's the only location where I can write it to. And then when I shoot that request up, you can see that I got the source here, looking through my ngrok. Yeah, I wrapped it in base64 so I can get it as an HTML. I'm going to just decode that. Very slowly. I got all the packages and the code index.js, so only left for me is to look inside the index.js, and I got the source code of the function running on the backend, on the application. So I cannot really run code shell on the server because there is no server, but I can still code. And I can steal that, and now I can investigate that. I cut that because we don't have time. I can see everything that goes here and then continue my attacks, of course, to steal some more sensitive information. All right. Crap, I lost 1 second. We don't need that. Okay. Okay. 2, broken authentication. Again, this is very brief. We don't have much time to go through 10. So you can, after the talk, of course, go to the documentation and read more examples. Broken authentication. So the functions are stateless. If you think about how it works, when the container spins up and the function starts running, it doesn't have anything that it's built in. There is no session or something like that. You have to take care of that by yourself. So the functions are stateless. They don't know what's going on before or after. So you have to take care of that. Again, multiple entry points, services, events, and triggers can cause a broken authentication because if you're thinking about, okay, it's an API gateway, I'll put everything there. But not all your code will run through API gateway. In fact, according to our customers, about 70%, roughly are going through API gateway. 30% of the traffic is not coming through API gateway. That means that putting the authentication there won't work for all cases. And in fact, we saw that with some customers that were assuming that if the request or that the function is triggered outside of the API gateway, no one really is going to be able to attack it. But that was not true, not the case. You could attack through different events. So, for example, this is a scenario where you can use your code commits and code control over, for example, this AWS. You can go use the code commit service, and it sends an automatic notification to the manager to go to review the code. And once the manager approves the code, there is a Lambda function that does something into the integrations or whatever we want. But if we do not protect also these parts, a malicious user can just send an email. Yeah, of course, you have to learn something about the environment to be able to attack, but we know that's possible. Right? We're a security conference, I don't have to preach that. So an attacker can just send an email that will trigger an SES, an email event that will trigger the function, so thus bypassing the authentication. Okay, sensitive data exposure. So it's the same as any cloud risk. Well, of course, if you are in the cloud, there is the risk, although it's not really a risk anymore. I'm trusting Azure and AWS. I'm trusting you more than I trust my own, I don't know, DevOps or something to store the data. So, but the risks are the same. The thing that what you are going to target are different. So the data that the application interacts with or creating or modifying is always stored in one location. It's the /temp, because any data that you want to process has to get there because it's the only right folder. So if you have access to the function through injections or whatever, you want to steal that data out of the /temp. Now, before I said it's going to be terminated once the function ends its execution, but that is not completely true. They have something for performance where they recycle containers if there is enough requests. So you can actually keep old containers alive if you keep requesting more and more scaling the data, scaling the application. So you can keep the data to remain, and you can steal customer data. Environment variables in the environment also contain sensitive data, and we'll see that later. So actually the keys for the function, the session keys, what the function can actually do in the environment, in the cloud, is stored there. So also that you can steal. Sensitive data in open buckets and open blobs, and any cloud storage that you do not configure correctly will end up. And we've seen in the news, you can look it up, many buckets are just open. And I don't have time. There is a website called Gray Warfare, I think, something like that. It's the showdown of buckets. So you can go there and start exploring buckets. You can if you want fake passports, go there. There is really everything there. You can find government files opened and any company that stores data in the cloud. Sometimes they leave that open. Source code we already saw. So the source code is also located in the environment, so you should be aware of that. Stealing keys. So if you want on AWS to get the keys, you just type env. So it's so if you have execute, instead of stealing the source code, I can just type env, get all the keys here. You can see session token and the XSI key, and all that I need is there. So if I have this, I can, from my own computer at home, I can communicate or interact with the cloud of the company. So it's enough that I have access to one function, then I can do whatever this function can do from my own computer. I don't have to interact with the function anymore. I just store those on my computer, and then I use API calls directly to the server. Yes. Okay. Stealing function keys. We just saw that. So I have the keys. I stole the keys. Now all I have to do is AWS, this is an example, AWS DynamoDB, list tables with those keys. This is from my computer at home. And I can get all the tables in the company's cloud account. Again, depends on the permissions. A4, XML, XXC. So it's going to be the same. I don't have to explain more about XXC. The only difference is that this is code that we found in GitHub. It exists. So it exists. So the only difference, if we were used to do something like that, let's see, password was our crown jewel. We don't need that anymore. In fact, this file is useless because it's a regular template file on the container. So what we can do or want to do is something like that, which will give us the source code. So the attack is the same. What we need to steal or where we need to steal the data from is different. Broken access control. So this is a major problem, maybe the biggest problem today. Functions are overprivileged because no one is able to actually go through 5,000 different actions that the function is able to do manually and select the correct ones. Of course, you'll have to automate that, but what we've seen, 98% of all the thousands and thousands functions that we saw, 98% have overprivileged, some of them critical, some of them lower, but let's take an example, again from AWS, sorry, the other providers. So this is a simple code that reads a file from the cloud storage. So the developer, the manager tells the developer, go give me the permissions for the function, and he goes to the documentation on AWS.com and he gets this one. This one works because it allows the developer to do whatever he wants. So any action on S3 and any resource on S3, that works. But what's the problem? It's the security. It means that if the function is compromised, the attacker can do whatever he wants on any S3 bucket in the cloud account. So he goes and does some more research and he comes up with this. Okay, whatever action you can do, the function can do, but only on this specific bucket. That narrows it down, the attack surface. But if you can do that automatically maybe, or maybe you have a genius developer, then you can come, or a security team that is very good, you can come up with this, which tells you that the function now can only do get object from the database. So yes, it can be vulnerable. Yes, you can still get an object from the database, from the, cloud storage, but that is all you can do. And quickly, we're going to see the second and last video for well, that's a surprise. Oh, there it is. So I have a function that is vulnerable to command injection. We don't have time. So you can see here that what the function has in the permissions is S3, whatever, wildcard. So now I can do some, with the stolen keys, of course, some upload to a cloud storage. Now, I'm going to attack the function and still list all the objects in another bucket because I can do whatever I want in the account. How much time? Okay. And I got the request, all the objects in the bucket. Now I'm going to do, quickly, I'm going to change that to S3 put object only and only on this specific bucket. And now I'm going to do the same attacks over, deploy the function, of course, again. Yay. And then I'm going to run the same attacks. You can see that it works. It does the put object. But now when I do the list objects from the database, it's not going to work because the function cannot do that. It's not that the attacker is not able to do the same attack. It's just the function is blocked by the provider. So that's a good thing, that if you can do that. Okay, security configurations, again, open buckets, permissions, things like that can cause timeouts, can cause denial of service or denial of wallet. If you have too much timeout, can cause denial of service. If you give the function to lower concurrency abilities. It can cause also denial of service or denial of wallet if you allow too much. We're going to skip that demo. Cross-site scripting, again, it's the same attack coming from locations where you weren't expecting. So it can come from an SCS, from an email. If you'll join me at the DVSA talk later after this one, I'll show you a cross-site scripting coming from an email. So it's going to be cool. Deserialization is also the same, but we're going to target, different locations. So the deserialization will target here, env. And then I'm going to get the keys from the Lambda function into my computer and do that myself. 5 minutes, great. Vulnerable dependencies. So you heard, maybe some of you heard the sneak talk. This becomes a really problem, a real problem in our era. In serverless, it even increases. Why? Because the functions are usually that small, are usually a type of microservices architecture, and you give the function a specific action that you want it to do, and this is it. So in order to be able to do that specific action, it needs to bring up a bunch of dependencies. So usually what you will see in Cloud Functions is a lot of imports and then 100 lines of code. This is a typical function. So it's very common to come up with a vulnerable dependency. And and of course, all the examples that I showed you, or some of them and some that I'll show next, are due to vulnerable dependencies that brought your function some vulnerabilities. So even if you think your 100 lines of codes are okay, you still have thousands of lines of code that coming with them that might break your application down. Insufficient login and monitoring. So different from containers where you have to inspect and know what's in there, in the container. You get what you use or you get what you want. So if you want to interact with the service, you just talk to the service. You don't have anything that you don't know about. So that's a good thing, but you also have to create your own logging and monitoring. Well, you have it in the cloud account, but you have to inspect the services to know what's going on in your account. So if you just leave your functions to run, they will run, but you won't know what happens in your application because you cannot put anything in the network level. You have to go to the provider's logging resources and start filtering, so it's difficult. How do you find security events? It's difficult. So you have to come up with a plan to do that. Plus, you're going to see millions and millions of invocations if you have a production account to each of the functions, so you won't be able, it will be hard to understand what's going on. Can that be real complex? Yes. So this is an architecture of a serverless function. Each of them has a different function and resource. They become one application, but they are individuals, and you have to monitor each one separately. So yeah, we created OWASP DVSA, the vulnerable serverless application. It's also an open source, Twitter, and live version. It is now in the one, now right after this talk I'm going to run there, so you can join me. It's just a vulnerable, the first real world vulnerable serverless application. It's a working serverless with e-com flows that you can, they're all 100% serverless that you can hack and fix. That's it. Thank you. Thank you very much for joining me.